This is very easy topic. So if you remember circles, spheres is very easy one. If you really remember circles of +2 level, sphere is just an extension of a circle in a 3-dimensional geometry. Okay, the same concept is same. What is sphere? Sphere is locus of a point. Locus of a point A comma B comma C, maintaining a constant distance r units from a fixed point A comma B comma C. So obviously this is given as x minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. But you have general different forms of sphere equation. First one, central form. Central form. Central form. Take this one. This is called central form. Central form is equation of a sphere based on center. X minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. If center is origin, x square plus y square plus z square equal to r square. Next, general form. General form. X square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Plus d equal to 0. So center is minus u minus v minus w. Radius square root of u square plus v square plus w square minus d. Okay, u square plus v square plus w square minus d. Obviously, whenever the square root term is greater than or equal to 0, only then it is a real circle, so real sphere. If the square root term is negative, that means radius is imaginary, then it will be an imaginary sphere. Imaginary radius is imaginary sphere. It's not a real sphere then. So obviously, to have a real sphere, then square root term should always be greater than or equal to 0. And certain observations that you can see here is quite obviously the coefficient of x square, y square and z square are same always for equation of a sphere, and also the cross terms xy, yz, zx terms are missing. Okay, so coefficient of x square, y square, z square same, and the cross terms are missing. Okay, and the square root term u square plus v square w square minus d always greater than or equal to 0. There are all certain conditions there. Okay, now take a statement. The equation of a sphere. The equation of a sphere on the line joining the 2 points, x1, y1, z1, comma, x2, y2, z2 as extremities of diameter, is given by x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. X minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. It means that you have a diameter that is given. The extremities of the diameter are x1, y1, z1, and this is x2, y2, and z2. If x1, y1, z1, x2, y2, z2 are extremities of a diameter, then the equation of such a sphere is always given by this one. Very easy one again. Getting that is not such a difficult effort. Okay, it's very easy one to get also. Okay, this is also called as diameter form. Diameter form, central form, general form, diameter form. Now, my simple question for you now, very, very simple question. How many arbitrary constants are there in a general equation of a sphere? Any? 2 are. 4. A, B, C, R. A, B, C, R, or else U, V, W, D. So there are 4 arbitrary constants in the equation of a general equation of a sphere. That means you need to know 4 conditions to get particular equation of a sphere. Those 4 conditions can be given in different varieties. Lot many silly questions also can be there in this context. Okay, take one question like that. Find the equation of the sphere through the points. Find the equation of the sphere through the points 0, 0, 0, comma, 0, 1, minus 1, comma, minus 1, 2, 0, and 1, 2, 3. I don't want to solve these kind of questions, okay? 4 arbitrary constants, 4 equations, solve all the 4, you'll get U, V, W, D or A, B, C, R, whatever. Go home and try to do that. The answer is 7 times of x square plus y square plus z square minus 15x minus 25y plus 11z equal to 0. Given circle. Okay. Now just concentrate for 5 minutes. Very important concept. Will be useful for you in other things as well. Simple concept, useful one, which you would have already studied in your plus 2 level in terms of circles. If you remember, in circles, suppose I have a circle. If this circle is intersected by a line, so this is S, this is line. A circle, when it is intersected by a line, it intersects at 2 points. 2 points. Okay? Any circle passing through the points of intersection of the circle S and line L is given by S plus lambda L equal to 0, if you remember. That means any circle passing through the points of intersection is always given by S plus lambda L equal to 0. Now that is something which we can, is a basic level thing. Now we'll go to sphere and a plane. Let S equal to 0 be a sphere, P equal to 0 be a plane. So when a sphere is intersected by a plane, you will actually get circle of intersection. You will get actually circle of intersection, right? There may many questions in this particular context. What kind of questions we can expect? One type of a question is something to do with this. Any sphere passing through that circle of intersection of sphere and the plane is given by S plus lambda P equal to 0. Any sphere passing through the circle, here actually you will get a circle basically. It's a circle of intersection when a plane and a sphere intersect. Any sphere passing through that circle of intersection is always given by S plus lambda P equal to 0, right? Let us see this in a different angle. Let this be S1 is a new sphere. This is S1. Now, S equal to 0 is one sphere, S1 equal to 0 is another sphere. These two spheres intersect. When these two spheres intersect, also we will get a circle of intersection, right? Also we get a circle of intersection. That circle of intersection will always be in a plane. That circle of intersection will always be in a plane. That plane is given by S minus S1 equal to 0. S1 minus S equal to lambda P, that means P equal to 0. Are you getting? So S minus S1 or S1 minus S2, if you consider S1 equal to 0 as one sphere, S2 equal to 0 as another sphere, when these two spheres intersect, we will get a circle of intersection. That circle of intersection will always be in a plane. The equation of that plane is always given by S1 minus S2 equal to 0. Okay, clear? Such a plane is also called as radical plane. Radical plane anta. Such a plane is also called as radical plane. What is the definition of radical plane? We will see it later. Okay. Now, what kind of questions can be expected? One is, if sphere is given, plane is given. S plus lambda p equal to 0 gives me the infinite number of spheres passing through the circle of intersection of a sphere and a plane. So, S plus lambda p. I need to know one more condition to get the value of lambda. That can be given in different ways. One is the new sphere is passing through a point, so that you will get lambda, or the new sphere is touching another plane, or the new sphere is intersecting another sphere orthogonally. That means at 90 degrees. Like this, there are different contexts that can be there. Okay. Now, when there are two spheres, if I take the difference between them, I'm getting a lower degree one, or maybe equal degree also sometimes you get, which always contains the common points of both these spheres. Okay, na? The curve of intersection is nothing but all the common points. The curve of intersection is nothing but all the common points of this surface and this surface. Both the surfaces common points will always be in some surface. That surface is given by the difference between these two surfaces. While taking the difference between these two surfaces, ensure that the coefficient of x square, y square, z square of one sphere is equal to the coefficients of x square, y square, z square of the other sphere. Because for one of them it is 2x square plus 2y square plus 2z square plus so and so. Other is x square plus y square plus z square. If you take the difference, again you will get another sphere. Because it should not be another sphere. The difference will always be a plane of lower degree, obviously of first degree. For that to happen, you need to have the coefficients of x square, y square, z square of first sphere and x square, y square, z square second sphere has to be same. Such a plane is also called as radical plane. Radical plane. Okay? Now, some other questions also can be expected. Now, if a plane and a sphere intersect, you will get a circle, or two spheres intersect, you will get a circle. The question can be, what is the radius of the circle of intersection? What is the center of circle of intersection? And for that matter, this circle is always given by s equal to 0 equal to p. Circle also doesn't have a single equation in three-dimensional geometry. All two-dimensional geometry figures, all two-dimensional geometry diagrams that we know, straight line, circle, ellipse, parabola, hyperbola, they don't have a single equation to represent in three-dimensional geometry. In three-dimensional geometry, all these two-dimensional figures, they become cylinders. For example, if I take a circle in xy plane and say that x square plus y square equal to r square is a circle in xy plane. But if I say x square plus y square equal to r square in 3D, in three-dimensional geometry, it's not a circle anymore. It's not even a sphere. It is actually a cylinder, which is a circular cylinder, x square plus y square equal to r square, whose axis is along z axis. Even parabola, hyperbola, ellipse, straight line, all of them become a plane actually. Sorry, they become a cylinder. Are you getting? Whose axis is along z axis, right? Even circle here, the circle of intersection that I got will always be represented in three-dimensional geometry as intersection of two surfaces. The two surfaces can be two spheres, or those two surfaces can be one sphere and a plane, or some other two also. A cylinder and a plane, a cone and a plane also can intersect and give size to a circle also. So whatever it might be, you always represent in terms of S equal to 0 equal to P or S1 equal to 0 equal to S2. They actually represent circles in 3-dimension geometry. Clear? Okay. For such a circle, what is the center of the circle? What is the radius of the circle? Okay. Now when you look at, this is suppose center, this is C1, this is C2. This is R, right? And this actually is capital R of this sphere. Is it okay? Capital R means this in fact is capital R. This is small r. Okay, this is small r. If you know this distance, perpendicular distance, from the center of the sphere to the plane, from the center of the sphere to the plane, if I know the perpendicular distance, then h square plus small r square equal to capital R square. H square plus small r square equal to capital R square. Capital R I can find, h I can find, therefore I can find radius of the circle of intersection. Then what would be the center of circle of intersection? Is nothing but the foot of the perpendicular of the center of the sphere projected on the radical plane. Is nothing but the foot of the perpendicular. Are you getting that? ఇంకోటి ఏదో అనుకున్నాను ఈ కాన్సెప్ట్ చెప్పేసారు అదే గురించి ఓకే ఫైన్ ఇంకోటి చెప్తా రాడికల్ ప్లేన్ వాట్ ఈజ్ రాడికల్ ప్లేన్ అంటే అన్నీ ఒకే దగ్గర చెప్పేస్తున్నాను నేను కాన్సెప్ట్స్ అన్ని because each concept is dealt separately in textbooks. First they intersect one sphere and a plane, they do some questions, and then one sphere and another sphere, some more questions, okay, and then a sphere and a plane intersect gives me circle of intersection, what is the center and radius of that circle of intersection. They go one after the other actually, okay, and then finally comes what is radical plane, like this. So I am trying to tell, because the context is same, so I am trying to tell you all the concepts at one instance. Radical plane. So first of all, what is radical plane? Suppose there are two spheres. There are two spheres. Okay. Now I can always find locus of certain points which actually gives me a plane, which would be something like this, from which if I draw tangent lines to the sphere, they will always be of equal length. Such a plane is called radical plane. Let me repeat. First of all, suppose there is a point x1, y1, z1. Suppose this is s equal to 0, is a sphere. The length of the tangent drawn from an external point onto the sphere is always given by square root of s11. I don't know how many of you remember this one. Square root of s11 gives me the length of the tangent drawn from an external point to the sphere. First thing is, how many such tangent lines can be drawn from an external point to a sphere? Infinitely many. All of them will be of same length. All of them will be of same length. They cannot be of different length. From an external point, if you drop tangent lines to the sphere, all those tangent lines will be of same length, exactly equal to square root of s11. What is the meaning of s11? S11 means, in the equation of the sphere, you substitute in the place of x, y, z, substitute x1, y1, z1. So x1 square plus y1 square plus z1 square plus 2u x1 plus 2v y1 plus 2 double z1 plus d equal to 0 is the S11. So square root of S11 gives me length of the tangent drawn from the point x1, y1, z1 to the sphere s equal to 0. Okay. Suppose this is s dash. This would be square root of s dash 1, 1. The locus of such points which make equal lengths of tangents, equal tangents would be the tangent plane. That is square root of S11 equal to square root of S dash 11, which is nothing but S11 minus S dash 11 equal to 0. It's the same thing. It's the same thing, radical plane. We call it as a radical plane. Okay? It's not required that they have to intersect. It's not at all required that to have a radical plane, the spheres may not intersect. Not required. It's just that the tangent length should be same. So from any point you consider, whether you draw like this or you draw like this, you draw like this or you draw like this, these all would be same. These all would be same. Infinitely many can be drawn. All those tangent lengths would be same lengths. And all those points, locus of all those points is nothing but the radical plane, the expression of which is given by S minus S dash equal to 0, whatever. Right? That is radical plane. Now let us go for a scenario wherein both these planes touch each other. So both these spheres touch each other. Both the spheres touch each other. When both the spheres touch each other, the tangent plane, the common tangent plane itself becomes the radical plane. The common tangent plane itself becomes the radical plane. Not only that, the join of the centers of the two spheres, if you join the centers of two spheres, it will always make 90 degrees with the radical plane. It will always make 90 degrees with the radical plane, whether here or wherever. Okay? The common tangent plane becomes the radical. In fact, this is called transverse common tangent plane. There are two types of tangents, what we call direct common tangent, transverse common tangent. Direct common tangent means this is direct common tangent. Both the spheres will be in the same side of the tangent. Then we call it direct common tangent. If they are in opposite sides, then we call it transverse common tangent. So obviously we are going to get two direct common tangents, one transverse common tangent in the case of two spheres touching. In the case of this one, two transverse and two direct. Now suppose both of them intersect. Both of them intersect. You will get circle of intersection. The circle of intersection will be always be in a plane called as radical plane. Clear? Now, suppose there is a sphere. I am trying to expand your understanding. There is a sphere. There is a point on the sphere. There is a point on the sphere. Okay? Find equation of a sphere touching the sphere at that point. Now, getting the question? Find the equation of a sphere. Find the equation of a sphere touching this sphere at this point. How many such spheres can be there? Infinitely many spheres can be there which can touch my sphere at that point. All of them can be given in one expression. What would be that expression? మీ knowledge ని expand చేయండి. అదే మీకు చెప్పాల్సింది చెప్పేసా. Okay. Certain times it's better you try to imagine like this. Let that point be a point sphere. Point sphere means what? Radius equal to 0. Center is that point. Suppose this point is x1, y1, z1. Then the point sphere would be x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square equal to 0. Point sphere. It's a point is a sphere. The point can also be treated as a sphere with center at the point, radius equal to 0. Radius equal to 0. Are you getting that? Then this sphere is s equal to maybe s1 equal to 0 suppose. Then the point sphere, let it be s2 equal to 0. Equation of any sphere passing through the circle of intersection of S1 equal to 0 and S2 equal to 0 is given by S1 plus lambda S2 equal to 0. If two spheres are there intersecting, this is S1, S2. Any sphere passing through the circle of intersection of these two spheres can also be given by S1 plus lambda S2 equal to 0. Here also I am doing the same thing. What I am trying to do, let this be a point sphere. S1 equal to 0 is the given sphere. At that point sphere I have S2 equal to 0 with 0 radius. Okay. The intersection of these two is again a point which will be in a plane called as tangent plane, which is the radical plane of S1 and S2. Will it be? The plane, the tangent plane at the point is nothing but the radical plane of S1 and S2. So now you can start constructing so many spheres. So many spheres. You can treat this as a radical plane P. P can be written as S1 minus S2 equal to 0 also. Are you getting? S2 where S2 is a point sphere, S1 is the given sphere. So any sphere passing through the circle of intersection of this sphere and the point sphere is given by S1 plus lambda S2 equal to 0 or S1 plus lambda P equal to 0, or you can do whatever you like. All such spheres will always touch this sphere at this point. Because for that, for those spheres, even this radical plane is on nothing but the tangent plane. For all those spheres, the radical plane is the same plane. You understand that? Clear? And not only that, suppose these two spheres are intersecting. These two spheres are intersecting. This is the radical plane. Any sphere passing through this sphere and this also will have the same radical plane. Are you getting what I am saying? Not only that, there are so many infinite number of spheres you can draw. The pair, this one and this one, intersection gives me the same circle of intersection. Are you getting? So take one from here, second from here. For both of them, the radical plane is same. Understanding? So it's all about one concept only. It's not multiple concepts here. It's about one single concept. If I further extend this concept, this place to channel the questions, I'm telling you. This is the place where in spheres you will get questions. In fact, if you understand this, this is end of sphere also. Okay? Now, an extension of this would be, suppose I have two spheres for which I have radical plane. Okay? Take a third sphere. Every two spheres will have a radical plane. These two also will have a radical plane. These two will also have a radical plane. These three radical planes intersect in a line called as radical line, because it's an intersection of planes. It is intersection of planes, which gives me radical line. How to get the equation of radical line? Suppose S1, S2, S3. S1 minus S2 equal to 0 gives me one radical plane. S2 minus S3 equal to 0 gives me second radical plane. These two planes intersect and gives me radical line. The radical line you can get in the symmetric form or general form also. Once you get the general form, you can convert into symmetric form. Let me extend this again. Take a fourth sphere. Take a fourth sphere. Every three combination, every three spheres will have a radical line. 4C3. 4C3. Permutations, combinations, if you recollect. 4C3 means 4. There are 4 such combinations of 3 pairs. This 3, this 3, this 3, this 3. Each 3 set will have one radical line. All these radical lines meet at a point called as a radical point, or also called as a radical center. That is the end of sphere.